goes up, return the loop iteration for next. And then we started talking about palette, define palette and palette commands. So we continue here. The define palette. The define. Okay. Okay. Everything's good. Okay.
The screen just came down further than it does.
Okay. And maybe it goes. A little bit, okay, but I'm afraid. Oh no, really? Yeah, okay. Yes, okay. Oh no, what's what? Oh. Oh, okay. I don't know. It's malfunctioning. I'm innocent. I need the witness to support me. I'm kidding. I'm kidding. The define palette. Last time I told you what is a palette. Palette means a grid. Okay. I can use my comb as an example for the palette. Okay? So here's the palette. It means something, and they are arranged in some pattern, especially in the company, in this is the working place. We want to, for example, in this is Sam's, the Costco, this is wholesale, this is stores, they have a huge amount of work pieces, items, products, and they want to move from this is the palette, one palette which is defined and according to some patterns, and to move items from one palette to another one. So if this is the case, if we use human labors, that will be very, very tedious, right? You guys agree? And very, very tedious. Also, sometimes, as I said, our human being, sometimes we are emotional, right? You guys agree? And how can we just automate this system to move blocks, items, products from one grid, we call grid or palette, from one palette to another palette. So in order to do this, you need to teach what this is the first palette is, and what the final palette is, and then you need to teach this is the palette, teach the industrial robots and how you want to move the items from palette 1 and to palette 2. So this is automation. So as I said, industrial robots, and they are very, very highly sophisticated, but still they cannot think. No matter how you say the AI or whatever machine learning, these kind of things, you say I implemented all these algorithms here. No, still they cannot behave like a human, right? So there's a good thing. That means they cannot replace us. However, you need to teach is what the palette is and how you want to move from palette 1 and to palette 2. So first, in order to define a palette, and you need to have these arguments. Last time I told you. So this is the format: define. def is a keyword, and palette is keyword, and the palette number, because usually we will handle multiple palettes, so you need to specify which is which. And the palette number 1, and then we have 4 points here: point 1, point 2, point 3, and point 4. And these 4 points, they are used to define the area, right? To define the area. Last time I told you the palette 1, the start point, end point I'm going to use. And then we have quantity A and quantity B. And quantity A is to use to define how many items in the first direction. And quantity B is used to define how many items are in the second direction. All right? You understand, guys? And then the assignment direction. Assignment direction, I told you, and we have linear same direction, and we have zigzag, and we even have this 3 when this assignment direction equals 3. That means it's one-dimensional palette. And to better illustrate how we define the palette, and we are going to use this is example. You can see this is zigzag, one the number equals 1, and this is a zigzag. On the same direction, we use 2. The arc palette is one-dimensional, just like this conveyor belt. Okay, so in the conveyor belt and in our lab, and I'm going to ask you guys to define a palette on this is a conveyor belt. Conveyor belt is 1D, right? So this is arc palette. So this is direction of palette equals 3. And so this is, you can just take a look at this one. But I'm going to use this to illustrate how we define the palette. So look at here, guys. I want to use this one. Okay, so you have 3 points. So this one you can see. So this is the palette. Okay, we'll have so many palettes here, and we have, suppose we put all these products on each of this block, right? And so you can see here. Okay, we have, this is our start point, and this is left bottom. Keep in mind, guys. So this is the when you define the palette, you need to follow his convention. And the left bottom is the first point, and the right bottom is the second point, and the third this is left top is the third point, and this is right top is the fourth one, is the fourth point. All right, you need to define these 4 points first, and then you need to define on how many the items, how many products in the first direction. And first direction is always the x direction. And you can, for this case, and we have 1, 2, 3. We have 3 items in our first direction. However, in the second direction, we have 1, 2, 3, 4. And for the second direction, we have 4. For this one, okay, 1, 2, 3, and 4, 5, 6. That means when I just pick up these items on this palette, 1, 2, 3, 4, 5, 6, I go this way, and this is zigzag, right? Do you guys agree? So as a result, the assignment direction number, and for this case, should be assigned 1. You have sense? So on the contrary, so you can see, and even so, this palette and this palette, they have the same points, right? And I say start point, end point, and so this is left top and right top, and they have the same points. And however, this time when I pick up the palettes, I want always, for each of these rows, I want to pick up the palettes from left to right, the same direction. As a result, assignment direction equals 2. You understand, guys? And you can see the difference, right? So when this guy is 1 and when this guy is 2, did you see the difference between these 2 palettes? You see the difference, right? And the sequence, I'm going to pick up the palettes. They are different, even though the dimensions of these palette, 2 palettes are the same. You understand, guys? Okay. And then here's arc. And so this arc, this is, even though this is curved, but if you want to define a single dimensional, one dimensional, for example, the conveyor belt, as I said, I'm going to ask you guys to define a palette on the conveyor belt. Conveyor belt is very, very long but narrow, right? Well, narrow means that in the witness direction, you can only put 1 block, 1 product at one so it is 1 by 1. So as I said, for that one, assignment direction needs to be assigned to 3. Questions so far? So these numbers, these 3 number, this number matters. Okay, they will change the pickup pattern when you palletize. Now here, so this one give you a better example. So this one you can see. So this is a conveyor belt 1. So 1 direction. So this is in 1 direction. This equals 3. For this case, guys, And for this case, I have 4 points. One, I always you need to keep in mind, okay? So left bottom is the first point. Right bottom is the second point. And so this is left top is a third point. And the right top is a fourth point. And if you mess up the order of these 4 points, the system will be confused. You understand, guys? As I said, industrial robot cannot think. They have convention there. You need to teach it based on the convention. And so I have in first direction, in X direction, I have 3 pieces or 3 items, 1, 2, 3. And in the second direction, that means in the Y direction, I have 4 or 5 pieces, 1, 2, 3, 4, 5. So that's the reason the statement I define this one as, this is P palette, and this is a P1, okay? So this is a palette P1, palette 1, P2, P3, P4, P5, P2, P3, P4, P5. And in first direction, I have 3 pieces. In the second direction, I have 5. So direction, okay, for this is for each of these zone, I use the 2. That means I use the same direction from the left to the right. Questions, guys? Questions? So no question. Let's look at this is a single row. Okay, this is a single row, and I also need to have these 4 points. So this guy's palette number is 8, and still have P2, P3, P4, P5. And in the first direction, and we have 5. In the second direction, and because it's single, and we have 1. So here is use a 2. Okay, there's a 1 direction. So there is use a 2 here. So for this is a 2 here. Any questions regarding this statement and this statement? Clayton, I think you are thinking. So here, this one is kind of tricky. So this one is tricky. I want you guys to write down, okay? Why this one is tricky? Because for 2 dimension, I have 1, 2, 3, 4. I have 4 distinct points, right? However, for the single row, and you also need to define 1, 2, 3, 4 points. But these 4 points, they are not distinct. Pay attention to what I say, okay? For this single row, I want you guys to write down, for the single row, first point, third point are identical. First point and third point, and they are identical. Second point and fourth point, they are identical. Can somebody tell me why? Can somebody tell me why? Can somebody tell me why, guys?
Because if it's just one line, the first and the third point are gonna line up at the same spot, and the fourth and the second point are also gonna line up at the same spot because it's not a grid, it's just a singular line.
Yeah. Yeah, okay, this is what how Aiden explains. So let me repeat, okay? So for a single row, first point, third point must be identical. Second point and fourth point must be identical. Why? I want to show you guys. look at this. This is a rectangular shape, and for this case, for this two-dimensional, it's very easy. I have 4 points. This corner 1, corner 2, corner 3, and corner 4. You guys agree? So for this is two-dimensional. So these 4 points, they are distinct. This is my first point, second point, third point, and fourth point. And however, for single row, for single row, I only have pieces in this direction, but in this second direction, I only have one single line. That means I can just bend this is rectangular shape. That means this point, they are identical. Second point and fourth point, they are identical. So you need to be very, very careful. And based on my prior teaching experience, a lot of students, they are confused. Okay? A lot of students, they are confused. Why they are confused? And in our palette, and we only have the 4. We only have these 4 blocks. We only have these 4 blocks. These 4 blocks, and you need to use this one and this one, right? So this one is the first point, and second point, third point, and the fourth point. And then you use all the 4 points as these 4 points. And however, if we have in this dimension, if we have 100, and in this dimension, if we have 1000, and we still use these 4 corner points, and we do not use any intermediate points. And I want you guys to know that. You understand? Why? Because if you go through all these points, that means there's no significance to palletizing. And what is the significance for palletizing? And you want to automate this system. You want to save energy and save the human labors. You guys agree? So you only need to define these 4 points, and also the assumption is that within these 2 points, so these 100 pieces, they are evenly spaced. And also in this dimension, and between these 2 points, so these 1000 pieces, they are evenly spaced as well. So this is our huge assumption. You understand, guys? So I want you guys to know, for the single row palette, first point and third point must be identical. Second point and fourth point must be identical. If this convention is violated, and you will see the industrial robot will behave like a monster. What? You have no control. Bless you.
Thank you.
Guys? So we will do the palletizing. Our first lab will be familiarizing yourself with our industrial robots, and second lab, and we will do the palletizing. We will palletizing from this is 2x2 pallet and to this is single pallet, and this is a lot of fun.
At the end of each statement, what is the 512? What is the difference between that and the 352 and the 4 point?
Oh, 5. This 5 means that in the first direction I have 5 pieces. Okay.
Okay.
So this number, the first number, is the number of pieces in the first direction. Second number is the number of pieces in my second direction, y direction. And third number is the direction. Okay, how are you going to pick the blocks? If this guy equals 1, it's a zigzag, go this way. If this guy equals 2, that means always from left to bottom for each of rows. Left to the right, left to the right, left to the right. If this is 3, that's an arc. Question so far? Look at this one. 3, 5, 2. 3 means in this direction we have 3 blocks. In these directions we have 5 blocks. And then for each of these rows, and we pick this is the block from left to right. Okay? 1, 2, 3, then 4, 5, 6. However, if this number equals 1, it will go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can see the difference, right? Questions so far? Okay, define palette. You can just take a look. Define palette number. So this example on how to define the palette, right? So we have for here, we define palette 2. You can see DLL low level for it, low left, low right, up left, up right. 6 is the number of pieces in first direction is 6. 1 number of pieces in the second direction is 1. That means single row palette. The 2 is the same direction from left to right. So then we define the offset value in z direction 50 millimeter, and then you can see there is a 4 next loop, right? So whenever you define a palette, and you will use the 4 next loop, for this automation. This you can see we use count 1 to 6, and then we have pp 2 and parentheses and palette 2 micron this count, and then you just move to the place right just above this pp2, and then move straightly onto pp2. Then you close your hand, and then you retract your hand onto this offset place, and then to go to the p place. Okay, MVS p place. Open your hand, delay, and then you move back, retract your hand, and then go to the next count. So next index, next iteration. So this one only show us the first, only palette 1, the first palette. In our lab, and we will have 2 palettes, palette 1 and palette 2. And you pick up the palettes from the palette 1 and to the palette 2, to the grade 1 to the grade 2. Any 2 questions so far? Any questions? So this is very, very interesting lab, and I hope you guys will love it. So if there is no question, then we move on to talk what we call the define palette, okay? And now we talk about program control commands, input and output signals, interrupt, and stop program commands. So as I said, this is industrial robots, and they have their own language, programming language, just as the PLC. And then we talk about for each of these program language, and we have program control, the commands, input and output, interrupt, and stop program commands. So program control commands, and we have go to, on go to means that between on and go to there is a value, and you can specify the value and to determine if some condition is met, and then you are going to go to somewhere instead of just execute all these commands one by one. And the third one is if some condition is met, then you are going to do something. Otherwise, and you got to go to do something else, and then you had and if. So if you have the C++ or C programming language experience, and you will be very familiar with this structure, this command. If something some condition is met, then you are going to do something otherwise, and you are going to do something else. Finally, and if. Questions so far? So this is another one, select, case, and select. So this is another one, okay? So also this is very popular, commonly used, this is a structure in this C++ and C. And then the next one is wait. And wait for the variable to reach the designated value. So here are several commands here, and then we going to give you example. So first one, go to, and this is just a single statement, okay? Definitely before it, when we have several commands, but here, go to is a start fin, and start fin is a label, okay? In the program, and you will write fin something, and then here that means unconditionally the system will go to fin and go to this label directly. So this is one case, and second case is that on M1 go to 100, 200, 300. What does that mean? It means that the system will check the value of M1. You understand, right? If the M1 equals 1, then I'm going to go to the first label. If M1 equals 2, I'm going to the second label. After this, go to if M1 equals 3, I'm going to go to the third label. So 100, 200, 300, and they are the label, and they are the start of some command lines. Huh? So here, if M1 equals 1, if this condition is met, and then I'm going to go to label 100, otherwise I'm going to go to label 200. So this is another case. Any questions regarding these three examples? So we are learning things, okay? We are learning things. Whenever you see new things, don't be frustrated, and don't treat it as this is torture. And actually, this is opportunity. We are learning things. I'm learning new things every day also. Questions so far? No question. And then we talk about here is the example for select. And select. So this is, as I said, this is very this is multi choice. So for select, okay. Also M1 is index. Let's say case is 11. If this M1 equals 11, if M1 equals 11, then I'm going to implement the commands in this space. And however, if this is M1 is less than 5, I'm going to implement commands here. And then if the case equals 6 to 9, okay, and then I'm going to do things located in between. So otherwise, for other case scenarios, I'm going to do something else. Before each of these commands, and you must have a break. One more time, okay? So I have 4 case scenarios. 1, 2, 3, 4. So for each of these case scenarios, you need to implement something here. Then you must end a break. Break is the keyword. Why? Because if you do not have break here, and they are going to, after finish this part, they will go do this one also. Have sense? And however, if this is you have a break after they finish these commands, and then we'll get out. Step out from this is a switch, from this select is a stop. Any questions? So this break is very important. So this is very similar to C++. C++, we have the very similar, not exactly very similar one, and also for each case scenarios at the very end, we have a break. This is we have break the keyword. So by the way, in the C++, the commands, the keywords, they are case sensitive. Okay, in C++ and C, and you must use the lowercase for the keywords command. Otherwise, the syntax error. But for here, we use as long as the system sees this word, no matter lowercase, uppercase, or combination, it's okay. Understand? So here is the end select. So this is the select. So another one is wait. I'm going to the system wait. System does not do anything until this is the bit 10 equals 1. Until bit 10 is turned on. So this is wait. Questions, guys? No question? And then we have input signal and output signal. And you can just input signal, and you can just, as I said, this is a microcontroller. Industrial robots, they are treated as a special microcontroller, and they can read the sensor's input. So how to do that? Input signal. You can just get this signal, get the status, from the input. And signals can be retrieved from an external device, and such as programmable logic controller. And so Frank and we plan to connect the PLC with the industrial robots to do something fancy. And we are going to do this one. If you are interested, let me know, okay? So in the input signal is confirmed with the robot status variable. For example, I'm_in. So in, so this is for bit, right? You guys still remember? So here, wait until this is a bit 7 is turned on. And you can see, you can assign the input variable, input value to a variable M1. This is INB. And what is the difference between M_in and M_inb? Can somebody tell me?
Isn't INB checks the byte, the whole byte instead of just a bit?
Yeah. Okay. Yeah, that's correct. Okay, so IN, that means only check the bit, the single bit, the status of bit. INB means that I check the byte, BYTE. A byte contains 8 bits. You guys agree? 1 byte has 8 bits. So that means I'm in B means that I will get the byte, the 8 bits starting from bit 20. Questions so far? And then I have another one, M_in W. And W means what, guys? W means the 16 bits, right? The 16 bits, it means that I'm going to retrieve the input from bit 20. From bit 20 and to bit 22, totally 16 bits. Questions so far? And then I can also do, this is the logic AND operation. INB 16. This is I retrieve the bit information from bit 16 go to 8 bits. I do the AND logic AND with this HF0. Questions so far? And then this output. output we have this is we can output means that you can just turn on the output and to control something. Very similar to this input, but this is I'm output. So this one for the bit, for a single bit. You can see here same thing. This is a single bit. So this is for byte. It's for word. You can see clear those clears based on the output. We set the pattern. And out, I'm out 6. That means you set the bit 6 to 1. Out, I'm output 6, and you set output to 0. And here, output B is a byte, and you set reset. Okay, reset the bit 0, bit 8 from bit 8 to 8 bits and to 0. Output W20 0. That means from bit 20, and you will have 16 bits, and they are 0. And output 6. So this is let this guy equals 1. Bit 6 is 1 at the same time, and then delay for 0.5 seconds. And so you can just do, and this is the logic. So this end is a logic end. So here is H means a hexadecimal format. So 0 means 000, F means 1111. Questions regarding this slide? No question? No question? And we define the interrupt. So guys, do you have the idea what is the interrupt is, guys? So let me ask you on what ACT is. You have taken ACT, do you? No? If you have never taken ACT, I assume you must take SAT. Say something, guys. You finish your high school education in the US, right? And that means you either have taken ACT or SAT. Is that right?
Yes.
I'm kidding. I love you guys so much.
I had a friend who lost fantasy football, and he had to go back in college and take the ACT and get at least a 25 on it as punishment.
What? Say again?
I had a friend lose a bet, and he had to go back and take the ACT in college as punishment, and had to get at least a 25.
25, okay.
What do you get? I got like 26, I think. He had to actually study a little bit. But that's right. Just during the pandemic, so it was like a 6 to 8 hour every very nice.
Okay. Okay, guys. And you do not know interrupt. You know ACT, right? We define ACT here means that we are defining the interrupt. And have you guys ever heard of interrupt? Okay.
Yes. I just don't immediately remember what it is.
So interrupt also. Interrupt. If we do not put the interrupt in this context, whenever I say interrupt, what comes into your mind?
Me?
Yeah.
I don't know how I just interrupted your lecture to talk about fantasy football events.
Yeah, interrupt means that you just stop the currently going the process, right? Do something else. Is that right, guys?
Yeah.
So interrupt here is the same meaning. Within this context, in the computer world, interrupt means that I have a program is running. But there is the interrupt. Interrupt means that maybe there is some emergency the processor needs to handle. Okay? And then the processor needs to stop running this is currently going on this program. And then needs to handle something else. Right? Here, this is what interrupt means. Make sense? So let me give you one this metaphor. I'm teaching now, and you are engaged, you are motivated, right? And now this is the earthquake this is alarm goes off, what will happen? What we will do? And we will, I'm going to stop immediately, asking my students, go to the soccer field. Right? Why go to the soccer field? Because we don't want to be killed, right? This building might be collapsing in a very short time. So we go there if everything goes well, and then we come back to continue our talk. So this is called interrupt. And this is in the context of a computer is the same. So you need to define the interrupt. Okay, interrupt. You can see the interrupt, and it has the priority. It has priority, and just as this earthquake, or the earthquake, and this is warning always have the highest priority. Why? Because they can kill us immediately. Okay. So this guy has a priority number, highest priority. So whenever you define the interrupt, and you need to define the priority number, which one is the most important one? If it happens, it is life-threatening. It will have big impact on our lives and on our career, and we need to handle these kind of things immediately. For some other interrupts, and we can just put away until we just defuse this high priority and interrupts. You guys agree? Okay, so this is also a kind of time management and prioritizing on this skill. And so this is look at, if we just look at this one, it is not very intuitive, informative, and then we talk about here. Okay, so and you can see define the interrupt number one. You can see this is the highest priority, right? And highest priority. And so what it is, it means that if the input at bit 10 equals 1, if this guy happens, and so the system needs to stop the currently going process and to handle something else. To handle what? And you need to go to sub 100. Okay? So second one, I define ACT2 for the bit 11. If this guy equals 1, I need to go sub help. Whenever if you have a label, and you should put this star sign here, and then go to the L here. So this L, what is L and what is? L is described after the process. The interrupt process will be executed when the line being executed is completed. So this will be executed when the line being executed is completed. This is L. S is the interrupt process will be executed after robot decelerates in the shortest time and distance possible. So this is, we have subtle difference between L and S. So here is a third interrupt. Input bit 12, then go this sub and restart and comma S. So this is the three examples. And after you define them, and you need to have this ACT command. That's ACT, the priority number, and you need to enable it. And finally, at the end, you need to disable it. And I'm going to give you an example, guys. Right? So here is an example. First, I define the ACT, the bit 10. If the bit 10 equals 1, I need to go to the start interrupt. So here I need to start interrupt. Whenever you come to this is interrupt, first thing is that you must set this guy itself 0. That makes sense? Otherwise, it will go in the loop. Next thing. Okay? Whenever you just respond to this interrupt, first you need to disable this interrupt itself, and then you can handle, and then finally return 0. So here ACT1, okay. So here you define ACT, and then you need to enable it. If you define it but without enable it, the system does not consider it. You need to enable it. After you enable it, during this process, if the M in 10 equals 1, and then the system will go here directly instead of following this one. So the sub-program commands. So here is a for you can call program, and you can call this is program main call pill uncount pp and program, and this is a pill, and this is a rm fprm check pp. So this is for a multiple program, and we will not handle this, and we only handle one program.